So I just realized that this is actually number 11, not number 10. So I'm going to work number 10 right quick right here. Okay, so number 10 says, find an equation of the tangent line to the graph of the function f of x equals the square root of x minus 2 at the point 18,4. So I need a tangent line at the point 18,4. So 18 is my x, 4 is my y. And I need the slope. So I need to find the slope of this function at 18. So I need to find the derivative. So first off, I'm going to rewrite this as the quantity x minus 2 to the 1/2 power. And finding the derivative, I'm going to technically use the chain rule even though the derivative of the interior is 1. So power to the front of the outer function, 1/2 times leave the interior alone. Subtract 1 from the power, negative 1/2 times the derivative of the interior, which is 1. And so this is really 1 over 2 square roots of x minus 2. So if I'm trying to find the derivative at the point 18,4, this is only in terms of x, so I'm just going to plug in 18. So I've got 1 over 2 square roots of 18 minus 2, which is 16. That's 4. So the slope is 1/8. So there's my tangent line. Okay. Number 12. Find the slope of the graph of the function of the given value. So find the slope of this function when x equals negative 1. So f of x equals negative 2x squared plus 6x to the negative 2. And then I want to find f prime at negative 1. Well, first I need to find f prime of x, and then I'll plug in negative 1. So f prime of x is just power rule. Bring the 2 down, so negative 4x, subtract 1 from the power. And then bring the power down, so minus 12x, subtract 1 from the power. And then that simplifies down to negative 4x minus 12 over x cubed. Let's plug in negative 1. So that's going to be negative 4 times negative 1 minus 12 divided by negative 1 cubed. Ooh, okay. So that is going to be 4. Negative 1 cubed is negative 1. Negative 12 divided by negative 1 is positive 12. So the answer is going to be 16. That is number 12. Oh, interesting. Okay. Number 12. Dadgummit, Jennifer, that was 12. Okay. Number 13. Number 13 says find the derivative of the function f of x equals x to the 5th minus 9 over x to the 4th. So there's a couple different ways to do this. You could do the quotient rule, and I'll do that in a second, or you could do just the power rule, because these, like, there's only one term in the denominator, and when there's only one term in the denominator, you can split it up. So one way, quotient rule, so low d high, so 5x to the 4th, and the derivative of 9 is 0. Low d high minus high, which is x to the 5th minus 9 d low, which is 4x cubed, all over low low, which is x to the 4th squared, so that's x to the 8th. And then simplify, right? Well, I'm going to go ahead and simplify out an x to the 3rd from the top and the bottom, so that leaves me with an x. That's gone. This is x to the 5th, and then I'm going to distribute. So I'm going to have 5x to the 5th. I'm going to go ahead and distribute that and say minus 4x to the 5th, and then plus 36, all divided by x to the 5th. 5x to the 5th minus 4x to the 5th is x to the 5th. X to the 5th plus 36 over x to the 5th is just 1 plus 36 over x to the 5th. Now, if you did quotient rule and it was open-ended and I just asked you to find the derivative, you'd be fine, although you would try and distribute, simplify. But let's prove that we can also get that by doing this. This right here is also equivalent to x to the 5th divided by x to the 4th minus 9 divided by x to the 4th. This is when you have a single term, which is the same thing as saying 1 minus 9x to the negative 4th. So the derivative, just kidding, x. The derivative of that would be 1, and then bring that down, plus 36x to the, subtract 1 from the power, and that's a negative 5, and you can see how that is 1 plus 36 over x to the 5th. Alright, number 14. Number 14 is find the first two derivatives of the function f of x equals 2 over the cubed root of x plus 3 cosine, or 2x to the negative 1/3 plus 3 cosine. Find the first two derivatives. So f prime of x is negative 2/3 x to the subtracting from the power negative 4/3, and the derivative of cosine is negative sine, so negative 3 sine. And then f double prime, we bring the power down to the front, so that becomes positive 8/9 x to the subtract 1 from the power, negative 7/3, and then the derivative sign is cosine, so minus 3 cosine of x. And there we go. Now, if they wanted it, if you had to do multiple choice, it would probably be this. And this would be the equivalent. It would be positive 8 over 9x to the 7/3 minus 3 cosine. Okay. Number 15. It says, determine all the values of x, if any, at which the graph of the function has a horizontal tangent line. So horizontal tangent of this. So here we go. I don't know what I just said. X to the 4th minus 4x plus 4. Its derivative is 4x cubed minus 4. If I were to set that equal to 0, because a horizontal tangent means the slope is 0, the slope is horizontal, and a 0 slope is 0. Horizontal slope is 0 is what I'm going to say. 0 slope, whatever. Then I'm trying to figure out, when does 4x cubed minus 4 equal 0? Well, if you add the 4, divide by 4, you get x cubed equals 1, and that's when x equals 1. So the x value for when we have a horizontal tangent is x equals 1, and x equals 1 only. Alright, number 16. Number 16 says, suppose the position function for a free-falling object on a certain planet is given by this function. Position equals negative 16t squared plus v0 t initial velocity plus s0 initial position. A silver coin is dropped from the top of the building. So dropped means the initial velocity is 0. From a height, so the initial position, of 1,372 feet. Determine the average velocity of the coin over the time interval 3 to 4. Average velocity on the time interval from 3 to 4. So velocity is the derivative of position, and derivative is also another word for slope. So if you're finding the average velocity from 3 to 4, then you're finding the average slope. So we don't need to find velocity, we just need to deal with position. And here's what I know. My position function is actually negative 16t squared plus 0t, because it was dropped, plus 1,372. So if I want to find the average velocity, then I'm going to say the position at time 4 minus the position at time 3 over 4 times 3. A change in position is a change in feet, and a change in time, in this case, let's see, seconds. It doesn't mention a time interval, so we'll just say seconds. So feet per second. So when we do this, we're just going to plug in 4 into position and 3 into position and subtract and divide by 1. So that's going to be negative 16 times 4 squared plus 1,372 minus negative 16 times 3 squared plus 1,372 over 1. And the reason why I did it this way is so you can see that the 1,372 is actually simplify each other out, so I don't really care about them. So I've got negative 16 times 16, and then negative, so I got plus 16 times 9. And the reason why I left it like this is because I can see 16 16s minus 9 16s is 7 16, so it is negative 7 times 16. A 70 plus 42, so 112, negative 112. Let me make sure. Yeah. So negative 112 feet per second. Now, if you are in BC, then we've already talked about how to find average velocity given velocity. So if you actually found the derivative, you could say v of t equals, maybe I'm going to teach you this later, but v of t equals negative 32t, and then just that, because the derivative of this would be just that. And then you can say 1 over b minus a times the integral from a to b of velocity. And so remember, this is the average value of a function. So if it's velocity here, then you're finding average velocity. Okay. All right, that is number 16. Number 17. Number 17 says that the volume of a cube with side lengths s is given by volume equals side cubed. So 17. Find the rate of change of the volume with respect to s, interesting, dv ds, when s equals 6 centimeters. So when they ask for the rate of change of volume with respect to s, then and the function is in terms of s, then this is no longer a related rate where you have to worry about changing your or tacking on a dv dt or something like that, because it's dv ds. It's kind of like I said, y equals 2x, and I find the derivative dy dx equals 2, and you don't think, let me tack on a dx dx, because dx dx is 1. So in this case, dv, the derivative of volume with respect to s, so dv ds, is just 3s squared. So the rate of change at s equals 6 is just 3 times 30. Oh my gosh, what am I saying? 3 times 3. 3 times 36, which is 90 plus 18, so 108. And that would be in cubic centimeters per centimeter. So per centimeter change in side length, you've got 108 cubic centimeter change in volume. Okay. 18. '18 says find the derivative of this function. And that is 9 square roots of x times sine of x. So f prime, well, first off, I'm going to rewrite this as 9x to the 1/2 times sine. And this right here is a product of two functions, which means I need to use product rule. So first, times the derivative, second, the derivative of sine is cosine. Plus the derivative first, so I'm going to bring the 1/2 down, 9/2 x, subtract 1 from the power, times the second. So this is 9 square roots of cosine plus 9 over 2 square roots of x, and then times sine. If we did a common denominator, it would be 2 square roots of x. So I'm going to multiply by 2 square roots of x, and I'm left with 18x cosine plus 9 sine, all over the common denominator, 2 square roots of x. Just know that at multiple choice, it would never leave it as a product or as a sum. It would leave it as a single fraction. So number 19, use the quotient rule to differentiate the function. 8x over x to the 5th plus 3. Now the reason why we can't split this up is because you've got an addition in the denominator. You can only split up a fraction if there's a single term in the denominator, and this is not. So if this is f, then f prime would be low d high minus high, and then d low is 5x to the 4th, all over low, so x to the 5th plus 3 quantity squared. We're going to simplify the numerator. That's going to be 8x to the 5th plus 24 minus 40x to the 5th. 8x to the 5th minus 40x to the 5th is negative 32x to the 5th, so negative 32x to the 5th plus 24 all over x to the fifth plus 3 quantity squared. And there's your answer. Number 20. Find the derivative of the algebraic function f of x equals x times 3 minus 4 over x plus 6. Okay. You could do product rule. I wouldn't know. I think I'd probably distribute the x and then work it from there. So I think I'm going to say this is the same thing as 3x minus 4x divided by x plus 6. So 4x over x plus 6 you could work two different ways. You could think of it as 4x times x plus 6 to the negative 1 and do product rule. It's just whatever you want to do. And then I'm probably just going to do quotient rule. Yeah, probably. So the derivative of 3x is 3, and the derivative of this is going to be I'm going to take a negative with it so I don't have to think about it as far as distributing it goes. Low d high, the derivative of negative 4x is negative 4. Minus high, so plus 4x, d low, which is 1, all over low low, x plus 6 quantity squared. So that would be 3 plus, okay, so it's going to be negative 4x minus 24 plus 4x. The 4x's cancel each other out. So actually minus 24 over x plus 6 quantity squared. And that would be the first derivative. Although, if they wanted to do a common denominator, then you would say x plus 6 up here 3 times x plus 6 quantity squared, or x squared, plus 12x plus 36, distribute your 3, and then subtract 24 if you need to, but nah, we're good. Okay. 21. Find the derivative of the function sine of x over 2x plus cosine of x. So we're going to find the derivative of this. That is definitely going to require quotient rule, so here we go. Low d high minus high d low all over low low. So I've got 2x cosine plus cosine squared minus 2 sine plus sine squared. In the numerator, cosine squared plus sine squared is 1. So I've really got 2x cosine minus 2 sine plus 1 all over 2x plus cosine quantity squared. And that would be my answer. 22. Find the second derivative of this function. So 22. If f of x equals 9x sine of x plus 3 cosine of x, the second derivative, well, this right here is a product because I've got 9x times sine. Those are two different functions. So I'm going to do f prime equals first times the derivative of the second plus derivative of the first times the second. And then the derivative of 3 cosine is negative 3 sine. 9 sine minus 3 sine is actually 6 sine. So I'm going to go ahead and rewrite that. And then find the derivative again. Now, this will again require product rule. So first times the derivative of the second, the derivative of cosine is negative sine, plus derivative of the first, 9 times the second, plus the derivative of 6 sine, which is 6 cosine. Again, those can combine to 15, so negative 9x sine of x plus 15 cosine of x, and that would be my final answer for the second derivative. Okay. 23. I'm not going to be able to put 23 down there, so I'm going to go ahead and go up here. Determine all the values of x, if any, at which the graph of the function has a horizontal tangent. So that means when your slope is 0. So we're going to find the slope and set it equals 0. So y of x equals 6x over x minus 9 quantity squared. Y prime equals quotient rule low d high minus high d low. Now d low is a chain rule, kinda, but it doesn't require it because the derivative of the interior is 1. So 2 do the interior alone times, or erase the first power, times the derivative of the interior, which is 1, all over low, which is x minus 9 quantity to the 4th. So I'm going to distribute, yeah, I guess. Interesting. So this is x squared minus 18x plus 81 right here. So if I distribute my 6, I get 6x squared minus 60 plus 48, so 108 x 486 minus, I'm going to distribute a 12x, so minus 12x squared, and then plus 54x. Ugh, that's rude. Okay, now it's asking about a horizontal tangent. So a horizontal tangent only occurs when the numerator equals 0, not the denominator. So I'm not going to worry about x minus 9 to the 4th. I'm not going to put an equal sign because this whole expression does not equal this whole expression because I did not put my denominator. But I don't care about my denominator because I'm just trying to figure out where it equals 0. I care in the fact that it can't be 9. But anyway, I've got negative 6x squared minus 54x plus 486 equals 0. I'm going to divide by a negative 6. So I've got x squared plus 9x, and then, what did we just say? 6 times 81, so minus 81 equals 0. Is that a factor? Should make sure I didn't do anything wrong. So low d high minus high d low all over limit x squared minus 18x plus 81 times 6. 6x squared. Okay. Okay. I've never broken down 81 like that. 81 is 9 times 9, which is 3 times 3 times 3 times 3. So I'm going to add up to 9. They're saying that the answer is negative 9, but I'm confused about whether or not this is the original problem. Can you do the quadratic formula quick? That's 5 times 81. It's not a perfect square. They said their answer is negative 9, but I'm not seeing it with this problem. Okay. So we got negative 9 plus and minus 9 root 5 all over 2. Not a perfect square. Negative 9 minus 9. Well, I guess that's both of them. I mean, that is what it is, so. Cool. Weird. Watch me be completely wrong and you guys have figured it out and I haven't. Oh, I'm an I am kind of an idiot. I don't know why I did that to myself. I could have made this a... Guys. Rude. Okay. I'm going to simplify. I should have done that from the very beginning. And feel free to laugh at me. Whatever. Okay. So right here, to make my life easier, I should have recognized that everything in the, every term, this being a term, this being a term, and this being a term, is divisible by x minus 9. So I could divide out an x minus 9, an x minus 9, and an x minus 9, leaving me with 6x minus 54 minus 12x over x minus 9 to the third. This will only equal 0 when the numerator equals 0, which is so ridiculous. Negative 9x minus 54. No, negative 6x. Wow. Okay. And that is true when x equals negative 9. Wow. Okay. Why the heckamaloo did not work up there? What did I do wrong? I said 6 times 9. I didn't say 12 times 9. Ugh. That's so sad. No wonder. 12 times 9, 90 plus 18, so 108. So those went away, and I was just left with this, and it would have worked out, and I'm wrong. That's okay. Oops. Well, that's kind of silly. Okay. Cool. So here I would get x squared equals 486 divided by 6. That's going to be 81. So x equals plus or minus 81. Interesting. Oh, but it can't be 9. It can't be 9 because 9 does not give you a horizontal tangent. It just is undefined. So that actually makes it a little bit more difficult. Plus and minus the square root of 81, Jennifer. So plus and minus 9, but only negative 9. Interesting. Cool. Wow. Math. 24. 24 says the radius of a right circular cylinder is given by this. So radius equals the square root of 3t minus 6, plus 6. And the height is given by t to the 5th, where t is the time in seconds and dimensions are in inches. Find the rate of the change of the volume of the cylinder with respect to time. So what is dV dt? Well, here's the thing. If volume equals pi r squared h cylinder, yeah. Then, and I was deriving like this, I would have to do product rule, I would have to do dr dt, I would have to stack on dh dt whenever I took the derivative of those, and this would be dv dt, blah, blah, blah. But they gave me a formula for radius in terms of time, and they gave me a formula for height in terms of time, which means t is the variable I'm deriving with respect to. You don't need to tack on anything. It's kind of like if I ask you to find the derivative of a polynomial, every time we took the derivative of x, you didn't tack on a dx because it's not necessary. So, volume equals pi. Radius squared, that's just going to be 3t plus 6 because it's the square root of 3t plus 6 squared. Times height, which is t to the 5th. You could go ahead and take the derivative as is. I'm going to go ahead and distribute my pi t to the 5th. So it's going to be 3 pi t to the 6th plus 6 pi t to the 5th dv dt equals 18 pi t to the 5th plus 30 pi t to the 4th, if you want to factor out the common factor, because you probably wouldn't leave it like that. The common factor would be 6 pi t to the 4th, and that would be 3t plus 5. And that would be dv dt. 25. 25 says find the derivative of the function, and it's got this function down. So x to the 8th times the square root of 5 minus 3x. So this is definitely a product rule and definitely a chain rule because you've got 5 minus 3x all raised to a single power. So I'm going to rewrite that as x to the 8th times 5 minus 3x to the 1/2 power. So the derivative is going to be first times the derivative of second. So 1/2, leave the interior alone, subtract 1 from the power, times the derivative of the interior. Okay, so first times the derivative of the second plus the derivative of the first. The derivative of the first is 8x to the 7th times the second, which I'm just going to go back to that being that. Square root of 5 minus 3x. Now, I'm going to simplify. I'm going to put everything in the denominator that belongs there. Negative 3x to the 8th belongs in the numerator. And 2 the square root of 5 minus 3x belongs in the denominator. Plus 8x to the 7th times the square root of 5 minus 3x. The common denominator would be 2 square roots of 5 minus 3x. And do that in a different color. 2 square roots of 5 minus 3x times 2 square roots of 5 minus 3x. And that would simplify down to negative 3x to the 8th plus 16x to the 7th times the quantity 5 minus 3x, which would simplify down to 80x to the 7th minus 48x to the 8th. So negative 3x to the 8th minus 48x to the 8th would be negative 51x to the 8th. So negative 51x to the 8th plus 80x to the 7th, all divided by 2 square roots of 5 minus 3x. Alright. '26. Find the derivative of this big old dude. G of x equals x plus 6 over x squared plus 7 all to the 4th power. Now, a couple different ways to do this actually. We could use logarithms, we could use product and chain and quotient. I don't know. I think I'll do chain, quotient first, and then maybe I'll explore the logarithms in just a minute. So, G prime, although I think it asks you to do that later. Yeah, okay. G prime equals 4, leave the interior alone, subtract 1 from the power, times the derivative of the interior. So the derivative of the interior is chain or quotient rule. So low d high minus high d low all over low low. So this is going to be x squared plus 7 minus 2x squared and then minus 12x. So we distribute the 2x, we get 2x squared plus 12x, and then distribute the negative. So x squared plus 7 minus 2x squared. So I've got 4 times x plus 6 over x squared plus 7. You know what? I'm going to go ahead and break those down. Cubed times x squared minus 2x squared is negative x squared. 7, that's just a 7, so minus 12x plus 7 all over x squared plus 7 to the 2nd. So I could say final answer is going to be 4 times x plus 6 to the 3rd times negative x squared minus 12x plus 7 all divided by x squared plus 7 to the 5th. And that's how we could, and I think that's how they left it as well. Cool. Might as well show you the logarithm, I guess. Yeah, I think I will. So if I let y equal x plus 6 over x squared plus 7, both to the 4th, or the whole thing to the 4th, whatever you want to do. You can use logarithms to differentiate a problem like this by throwing a log in front of both sides. a natural log. It doesn't really matter, but natural log is easy. So you can say natural log of y equals, and then you can bring the 4 down to the front and say, I wonder if I've done this. I don't think I've done this with AB. Maybe. I don't remember. 4, leave the natural log, okay. But I'm actually going to bring the 4 down to the front and expand the logarithm at the same time. When a logarithm is combined using a division, I can separate it using subtraction. So natural log of x plus 6 minus natural log of x squared plus 7. And then I can derive that. So this is this expression. So the derivative natural log of y. Let me check real quick. I mean, I guess we have. Yeah, looks like we have. It's just been a while. So the derivative natural log of y is 1 over y. And the derivative of natural log of anything is 1 over that thing times the derivative of that thing, right? Whoop, crap. 1 over y prime. So the derivative of natural log of y is 1 over y times the derivative of y, which is dy dx, or y prime. And this is 4 times the derivative of natural log of x plus 6, so 1 over x plus 6 times the derivative of x plus 6. Minus, I'm going to distribute my 4, so minus 4 times 1 over x squared plus 7, but times the derivative of x squared plus 7, which is 2x. So I actually get that y prime, or 1 over y prime, equals 4 over x plus 6 minus 8x over x squared plus 7. And then y prime, I'm going to, in order to solve for y prime, I'm going to multiply both sides by y. But y is this original function. So it would be 4 over x plus 6 minus 8x over x squared plus 7 times x plus 6 over x squared plus 7 quantity to the 4th. And let's see. If I multiply this times this, that would be 4 times x plus 6 cubed over x squared plus 7 minus 8x times x plus 6 to the 4th divided by x squared plus 7 squared, or to the 5th. And I'm not willing to find a common denominator and work that out. So that is going to be that. And it is. But we're showing it. Just show the work to get there. So that's 26. Let's go with 27. So 27 says, find the derivative of the function y equals 3/5 secant squared. The derivative of secant, well, the derivative of tangent is secant squared. We're not anti-deriving, we're just finding the derivative. So dy dx, or y prime, equals. I'm going to rewrite this in my mind as secant of x, well, and on paper, I guess, secant of x quantity squared, which means that's a chain rule. So I'm going to bring the power down to the front. So that's going to be 6/5, leave the interior alone, to the first power, times the derivative of the interior, which is secant tangent. The derivative of secant is secant tangent. Ooh, okay. And that means that my answer is, whoops. Okay. Got a little crazy. 6/5 secant squared tangent x. And there's my derivative. 28. Says find the derivative or differentiate the function f of x equals 5e to the 3x squared. The derivative of e to anything is e to that thing times the derivative of that thing, just chain rule. And there's a 5 hanging out front and it just stays there. So f prime equals 5e to the 3x squared times the derivative of the power of 3x squared. That's 6x, so my final answer is 30x e to the 3x squared. And there we go. Let's do 29 on the next page. So 29 says, differentiate the function f of x equals natural log of e to the 5x plus 1 over e to the 2x plus 1. I'm going to derive it as is, and then I'm going to use log properties to kind of make it simpler. So the derivative natural log of anything is 1 over that thing. So 1 over e to the 5x plus 1 over e to the 2x plus 1. Plus 1, Jennifer. Not in the power. Which 1 over a fraction is just the reciprocal of the fraction, right? So we'll simplify that. Times the derivative of the interior. So derivative natural log of anything, 1 over that thing times the derivative of that thing. So this would be quotient rule. So low d high, derivative e to the 5x is e to the 5x times derivative of the power, which is 5. Minus high, e to the 5x plus 1 d low, which is e to the 2x times the derivative of 2x, which is 2, and the derivative of 1 is 0. All over low, which is e to the 2x plus 1 quantity squared. So I have e to the 2x plus 1 over e to the 5x plus 1 times, I'm going to distribute this, so 5e to the 5x times e to the 2x. Remember, we can add the powers when you multiply. So 5e to the 7x plus 5e to the 5x minus, I'm going to distribute 2e to the 2x, so minus 2e to the 7x minus 2e to the 2x, all divided by e to the 2x plus 1 quantity squared. One of those can cancel out with one of those, leave me with 5e to the 7x plus 5e to the 5x minus 2e to the 2x, all divided by e to the 5x plus 1 times e to the 2x plus 1. We could still do some more distributing. We could factor out an e to the 2x from the top. Here's the other option. We can use log properties. So f of x equals the natural log of a quotient is the same thing as natural log of the numerator minus natural log of the denominator. And the derivative natural log of anything is 1 over that thing times the derivative of that thing. So f prime of x would equal 1 over e to the 5x plus 1 times the derivative of e to the 5x, which is e to the 5x times 5. Minus 1 over e to the 2x plus 1 times the derivative of e to the 2x, which is e to the 2x times 2. So final answer, 5e to the 5x over e to the 5x plus 1 minus 2e to the 2x over e to the 2x plus 1. And that is actually the answer that they gave. So cool. But it's not like this is wrong. It's just like a lot. Alright, let's do 30 and let that be the last one on this video. So 30 says differentiate the function f of x equals natural log of 8x squared minus 4x plus 11. So remember the derivative natural log of anything is 1 over that thing times the derivative of that thing. So f prime equals 1 over 8x squared minus 4x plus 11 times the derivative of that, which is 16x minus 4. So final answer, 16x minus 4 over 8x squared minus 4x plus 11.